No human has left Earth's orbit since December 1972. Every person alive under the age of 53 has never lived in a world where humans went to the moon. That changes on April 1st, 2026. Raw power fuels Artemis II's climb from the Florida coast. At liftoff, the Space Launch System's twin solid rocket boosters ignite first, each standing 177 feet tall and burning through over 1 million pounds of propellant in just over 2 minutes. Together with the massive orange core stage, they generate more than 8.8 million pounds of thrust, greater force than the Saturn V that once carried Apollo astronauts to the moon. The core stage, stretching 212 feet and built at the Michoud assembly facility, is driven by 4 RS-25 engines. 3 of these engines once flew on space shuttle missions, their heritage etched into every bolt and weld. The 4th is newly built, designed to endure the most punishing ascent NASA engineers can imagine. These engines must perform flawlessly. A single failure could end the mission before it truly begins. As the SLS thunders skyward, the America 250th anniversary logos on the boosters mark not only a celebration of the nation's founding, but a reminder. This is a national effort carrying the weight of half a century's lunar ambition. For Artemis II, reliable lift isn't just a technical requirement. It is the foundation for everything that follows in deep space. Stacked above the Space Launch System core, a series of specialized systems transforms launch energy into deep space capability. The Interim Cryogenic Propulsion Stage, ICPS, takes command after booster separation. This expendable upper stage, powered by a single RL-10 engine and fueled by supercooled hydrogen and oxygen, executes the precise burns needed to send Orion and its crew into high Earth orbit. Once its task is complete, ICPS becomes a target for Orion's proximity operations, a rehearsal for the docking maneuvers that future lunar missions will demand. Linking ICPS to Orion is the stage adapter, a compact ring housing avionics for autonomous docking. These systems, tucked inside the adapter's payload bay, are set for their first real test, laying the groundwork for future rendezvous with lunar landers or gateway modules. Orion itself is designed for survival far from Earth. Its European service module, built by Airbus for the European Space Agency, supplies propulsion, electrical power, thermal control, and life support. The main engine, inherited from the Space Shuttle's OMSE, will guide Orion onto its lunar path, while solar arrays and internal tanks provide power, water, oxygen, and nitrogen for the crew. Crowning the stack, the launch abort system stands ready to pull the capsule away from danger in milliseconds, safeguarding the astronauts during the riskiest moments of ascent. Each element in this upper stack must function flawlessly, integrating propulsion, life support, safety, and docking systems for the mission ahead. Within minutes of clearing the tower, Artemis II enters a new phase of complexity. The solid rocket boosters have done their job and fallen away, leaving the core stage to burn for another 6 minutes. As the core stage shuts down and separates, the interim cryogenic propulsion stage ignites, steering Orion and its crew into a parking orbit just above Earth. For the next hour and a half, the spacecraft circles the planet at over 17,000 miles per hour, systems humming as ground teams and crew verify every parameter. This is not a pause, it's a critical checkpoint. At the end of this first orbit, the interim cryogenic propulsion stage fires again, pushing Orion into an elongated path that will carry it more than 46,000 miles from Earth, far higher than the International Space Station or any typical satellite. This high apogee orbit is no routine lap. It is a trial by fire for the guidance, navigation and control systems that will one day handle Lunar rendezvous. For nearly 24 hours, Orion and its European service modules circle through the harsh environment above the Van Allen radiation belts, exposing hardware and life support systems to deep space conditions. During this phase, Orion separates from the interim cryogenic propulsion stage. The crew initiates a proximity operations demonstration using the capsule's autopilot and thrusters to maneuver around the spent upper stage. This rehearsal is more than a technical exercise. It is a direct simulation of the docking maneuvers required for future missions to the Gateway Lunar Station. Every command, every sensor reading, every pulse of the thrusters is a data point that will shape the future of human spaceflight. Success here means Artemis can move forward. A single misstep could halt lunar ambitions for years. Orion's journey out of Earth's grasp is not a straight shot to the moon. For 4 days, the spacecraft and its crew coast through deep space, following a precise free return arc. This trajectory is a legacy of Apollo, a path chosen for its ability to bring the crew safely home, even if the main engine fails. It is the same kind of route that turned disaster into survival for Apollo 13. For Artemis II, this is not just a backup plan, it is a calculated safeguard, a reminder that deep space offers no easy rescues and no margin for error. As the spacecraft approaches the moon, Orion passes within roughly 4,600 miles of the lunar surface. This is the closest any human beings have come to the moon in over half a century. On the far side, Earth falls below the horizon. For nearly an hour, the crew is cut off from all radio contact. The blackout leaves them alone in the silence, just as Apollo crews once were. In this span, no signal, no voice, no telemetry reaches mission control. The moment tests not only the reliability of onboard systems, but also the resolve and training of the astronauts, who must trust their ship and each other. After the lunar swing by, Orion swings back toward Earth on the return leg, retracing the free return path. The spacecraft must hit a narrow re-entry corridor, just a few degrees wide, at nearly 25,000 miles per hour. Too steep and the capsule risks burning up. Too shallow and it could skip off the atmosphere entirely. The crew's lives depend on guidance, navigation and heat shield performance being flawless. 4 days after leaving lunar distance, Orion plunges into the Pacific Ocean on April 10th, where recovery teams from the US Navy stand ready. Every phase of this arc is a trial of engineering, of human judgment, and of the systems that will determine the future of lunar exploration. Every critical system aboard Orion faces a battery of tests designed to measure, not just demonstrate, readiness for deep space. The environmental control and life support system is pushed to its limits, sustaining 4 people through simulated emergencies and high metabolic loads. Crew members perform aerobic exercise, forcing air purification and carbon dioxide removal units to operate at maximum capacity. Sensors track oxygen, humidity and trace contaminants, with each reading compared against strict thresholds. Any deviation triggers immediate analysis by ground teams. Radiation protection is assessed through a shelter drill, where the crew moves into Orion's most shielded compartment as if a solar particle event were imminent. Dosimeters record exposure, while the engineering team monitors real-time data to confirm that the capsule's shielding meets mission standards. Communications and navigation undergo blackout simulations, verifying that Orion can maintain safe operation even when cut off from Earth. Meanwhile, the docking autopilot is validated through closed-loop maneuvers around the spent ICPS, measuring position and velocity accuracy to within tight margins. Abort protocols are rehearsed in software and hardware, confirming that the launch abort system and backup engines can respond within milliseconds. Each result feeds directly into pass or fail criteria that will determine whether Artemis moves forward. 4 astronauts carry the weight of Artemis II's promise. Commander Reed Wiseman brings 167 days of spaceflight and years as a Navy pilot, trusted to steer the mission through the unpredictable. Victor Glover, serving as pilot, is a test pilot with experience in 40 aircraft and 24 combat missions, trained to handle split-second decisions that deep space demands. Christina Koch, mission specialist, holds the record for the longest single spaceflight by a woman, 328 days on the International Space Station, and her endurance and technical expertise are essential for operations far from Earth. Jeremy Hansen, also mission specialist, is a colonel and physicist at the Canadian Space Agency, the first non-US astronaut assigned to a lunar distance mission, representing the international partnership needed to sustain future exploration. Each brings unique skills, but together they form the human core of Artemis II's test. Every procedure, whether it is running life support drills, navigating blackout periods, or simulating emergency shelter, depends on their training and judgment. Their performance will set the bar for Artemis IV and all missions that follow. If they succeed, they open the gate to a new era of lunar exploration. If they falter, the path to the moon and beyond remains closed. Every booster, module and maneuver on this mission isn't just spectacle, it is a test with real consequences. Until the Space Launch System, Orion and the crew prove deep space readiness, the next steps, Gateway, landings and Artemis IV, remain out of reach. The moon is no longer a symbol, it is a threshold demanding proof.